We're continuing today section 3.3, long and synthetic division methods. We haven't started synthetic division yet, but we learned about long division. So we will just solve a very similar question to just like last time. But the difference this time is you have a longer expression. It's pretty long, right? And it's divided by also a quadratic second degree power 2 expression. It's not linear anymore. So that's the difference between this question we solved last time. It's a little bit longer now, and it's not linear like this. It's quadratic, square, okay? All right, how do we do this? We apply this recipe on the right side over and over, rinse and repeat. So we first set up this division as divisor comes here. Dividend comes here. Again, I've made a mistake. Not a mistake, but I technically should have done something here. What did I miss? Yeah, make sure everything is in descending over in order in powers 5, 4, 3, 2, 1, 0. And besides that, make sure all powers are visible. So I have fifth, fourth, and third powers present. And then the first power, what happened to second power? I need to make it visible. If the second power is missing, that means it's 0. I mean, 0, it has 0 coefficient. So I still put it 0x squared, and then continue writing the next items. It was minus 4x and 45. Same deal with the divisor. I have square 0x and minus 3. Okay? All right. Now, step 1, we mark the biggest exponent on the right and biggest exponent on the right and on the left, and we divide one into another one. This is x cubed, correct? 5 take away 2 is 3. Second, before going to the second part, take this x cubed and put it into quotients location. Now second, take that x cubed, the result, and multiply by the divisor. When you're doing that, you don't have to show the 0 term. Just do it with the non-zero terms. So it's x to the 6th minus 3x cubed. Is that correct? I have a mistake. I immediately noticed it. Why? Where is the mistake? Yeah, but how did I catch that mistake? How did I know it was a mistake? Because when I multiplied these two, the first term should be matching to this thing. And I have x to the 6. It's not matching. So I check my solution back, and 3x cubed times x squared. We don't multiply 3 and 2. We add them. So this is 5th power. Now we put this 5th power. Now recall that we need to make all the powers visible. I don't have anything after 5, but we are skipping the 3. So that means we have a 0x to the 4th and then minus 3x cubed. When you're using your results here, make sure all skipped powers are visible, okay? You don't have to show it here though. Okay, and now we start canceling, subtracting things because it's subtraction. And when I recall last time I told you to make this subtraction easy, just flip each and every sign of the terms and then add them. Minus 5 minus 0 is just minus 5 again. Pretty much nothing changes. And 19 take away minus 3 is 19 plus 3, so which is 22 of them. And what do I do with the rest of them? I just move them down because there is nothing underneath them. It's 0 squared and 0x and 0. Any questions so far? All right, we rinse and repeat. We restart this process again. I mark the highest degree of each side. Next time we have a lower power, fourth power, but still the x squared on the left, and the result is minus 5x squared. You always get one less degree power, and I put this right here. Second, I multiply minus 5x squared by the divisor, and the result is minus 5x to the fourth positive 25x. Is it 3, right? Yeah, thank you. So it's not 25 then. 15x squared. Alright, we bring this to here to subtract. When you're doing that, make sure you make visible those missing powers. And when I subtract these flip signs, they cancel. This is 22 x cubed minus 15x squared. Nothing else underneath these guys, so they just transfer down. Wow, okay. Now how far do we continue like this? Until, here is the criteria to stop or continue. Until this number becomes strictly less than 2, its power of the leading term of the left side. 2, you need to stay lower than that, which means 1. Until this becomes 1, I will keep going. So I mark this guy again and restart this two-step method. Once I divide 22x cubed over x squared, which is just 22x, right? And I put that right here. Is it negative or positive? Positive. Positive 22. And I take that 22x multiplied by the divisor, which is 22x cubed minus 66x, and I bring that down here and subtract. What's this? Oh, this is x to the fourth, right? Okay. I was confused, 2x squared there, right? Alright. Any questions so far? One more subtraction. These will cancel. These will flip signs and add. We will have minus 15x squared. These two guys. Just move it a little bit left. And these two guys make 62. Positive 62. And 45. I think this is where we stop, right? So we have a match between the powers. Now we go one more round. This is the last round. Alright. I take 15x squared and divide by the leading power of the left, and no more x left, but except 15. Spot mistakes and let me know. So I put here 15 then. Yes, this is not positive 15. It's minus y. So I made a mistake. The leading term is not just plus 15, but it's minus 15x squared. Alright, so that means I take minus 15 and multiply by the divisor, which is always x squared minus 3. End up getting minus 15x squared plus 45. I mean, you could have catch this mistake later as well. This number and this number must match. If you're getting positive 15 and this is negative 15, there's something wrong. Alright, now they are matching. Again, always and always, if there's a skipping power, make it visible and subtract. These will cancel because it becomes plus, minus, minus. 62 take away nothing is 62. 45 take away 45 is 0. Oh, great. Any mistakes? Which one? Minus?
45 minus, and then we change the sign to this, so it becomes negative.
It was positive earlier.
So I'm looking at it wrong because you changed the signs instead of changing the signs and add, which
Okay.
Yeah,
So either thing like this, 45 minus 45, or forget minus, flip this and add 45, add minus 45. Either way, okay?
Yeah.
So once I flip the sign, it's no longer subtraction, it's an addition. Addition if I flip the sign. Okay, 62x is remainder. Quotient is this. Divisor is already that. I think we have everything we need. Let's see what kind of answer is demanded in the question. Yeah, what does that mean? You will first start with the quotient. Let me first write it, quotient. And then you will have any remainder but it should be on top of the divisor, whatever divisor is. So divisor is x squared minus 3. So if there is any remainder, it goes to the top of this divisor, and the answer in the quotient, that green expression, will go here, okay? If the remainder is 0, for example, if there is 0 left, then this whole thing, the second part, drops out. All right, what is the quotient we found? X cubed minus 5x squared plus 22x minus 15. Move with arrow keys. X cubed minus 22x squared, was it? 5x squared. Minus?
Yes.
Positive 22. Minus 45, was it? Minus 15. Okay. That's it. Remainder was 62. X. Oh, not there. Go up with arrow key. 62x. Great. Okay. All right. Here are a couple of recommendations. Please, this is a long process. It looks like if we are doing it together, you catch mistakes quickly, but this question is prone to mistakes a lot. You can make easy mistakes here, and you won't get that correct sign in your first shot. It's okay. That's why I want you to work on a paper first. Don't do it on the screen or skip steps. Do it slowly on paper. So when you see the incorrect sign, you need to go back. Check every step you made one by one and fix your mistake. Okay? And I believe the system is not going to let you flip your question on the spot many times. I think after several times later, they will give you the answer and flip the question into a brand new one, and you have to restart another question. It's a waste of time. But again, don't make too many mistakes. All right, next, synthetic division. I said this is a special division method. It applies to only certain type of divisions last time. It requires this divisor to be linear. What do I mean by linear? X should have no other powers than 1. It should be x to the first, no squares or other powers. And there should be maybe a number following it, plus or minus number. That's linear. But that doesn't mean it's unimportant. No, this method is extremely important because we are going to apply it in the next section rather than long division, because long division, as I say, it's long procedure. This is faster, and finding zeros of polynomials is our next subject. This comes very handy in the next subject, so you need to know it. Okay, what is that procedure? I just took the example from your book, and let's first analyze this solution and see how they built this method. First, you take this number right after x, flip and put it here. Flip the sign. Flip the sign. Extremely important. Don't take here -4, but opposite sign +4. Got it? Second, you move all these numbers in front of x's. If there is a missing power still counted as 0, look, 0x is actually 0. Why did they put it here? Because we still need it here. And even the last number that has no x next to it, constant number, all 4 are lined up here. Okay? Makes sense so far? That's step 2. Step 3, you put a line here, draw a line, horizontal line, below the coefficients. That's it. But keep some space here, because we're gonna start putting numbers between these numbers and line. And all you need to do is bring this initial number with no operations. You don't have to do anything about it. Just bring it down, transfer it down. That's step 4. We bring the leading coefficient of the dividend down here without any change. Next, you always multiply the number under the horizontal line with 4 or divisor number and put it underneath the adjacent number. Next number is -10. You put the result here as 8. I'm at this step. And what operation do we do between -10 and 8? We used to do subtraction on this question. Here though, it's just basic addition. We add these two. Don't flip signs or anything. We already flipped the sign here, remember? So it kinda compensates for that. So you don't flip signs here, only add. -10 plus 8 is -2. What do I do with -2 again? You take this -2 and 4, multiply and put it here. Get a new number, take it, multiply and put it there. Again, 4 times -2 is -8. 0 plus -8 is -8. 4 times -8 is -32. And we add the final 2 numbers and you're done. We are done, but this answer doesn't make any sense. We need to change this answer into polynomial. starting with the last term. Last term is just constant. You don't attach anything to it. The second, no, this is called remainder, so it's not constant. So we'll put it aside somewhere else. We put it here, minus 37, it's remainder. Then we go here and write these three as a polynomial. How? This is a constant, you just move it down, and every time you have a number to the left, you add 1x to it. This is minus 2x. And this one is 2. You always increase the power. This has already x with first power. Here you increase to the next power square. Got it? So we don't do anything to this. You put it aside, it's remainder. And this number is constant. It has no x attachment. This one is x, this one is for x squared. If there is a third number, it would be x cubed, something x cubed, and then there's another number, x to the fourth, etc., etc. Yeah. So we will use this method rather than the long division to get the zeros because it's fast. What's that? Rational zeros, yeah, we will do Q over P test, yeah. P over Q, yep. Okay. All right. Now let's practice. All right, first I take this notation and put a line right here. Okay. Now, what number comes here? It's opposite of this one, is -1, perfect. And we need to just put all these numbers here in the given order to there, right? So there's 4, -2, -6, and -4. Am I right? No, I'm kidding, okay? So we need to first reorder these terms from highest exponent to lowest, and besides that, we need to make all missing powers visible. So we start with -4x to the fourth. Do we have a cube? No, so we put 0x cubed. Do we have a square? Yes, 6, -6 of them. And we have an x, and we have a number. This is the right order. That's what we need to put right here. -4, 0, -6, -2, and 4. Okay? Now first, you bring this down right here. Second, multiply and put it right here. The answer is +4. -1 times -4, +4. We add these and get 4. Multiply, put it here. -4, add -10. Multiply, put it right here. 10, add 8. -8, add -4. Again, multiplied, used it here, and we added. That's it. How fast? Can you see how fast this is comparing to long division? Instead of being making those two-step rinse and repeat process, this is just more efficient. But could have used this one with this was a square? No, I couldn't. Right? So I was lucky to be given a linear equation. We got it. All right, let's write the final answer. final answer will be quotient plus remainder over divisor. So what is the quotient? Remember, you look at only this part to write quotient. So what is that left out number on the variant then? It's the remainder. This remainder is -4. So it is -4 over divisor is already x plus 1, I know. So what is the quotient? Start with from the end. It's 8 plus 8. What is the number before that? And the number before? Positive x squared and negative 4x cubed. Okay? Oh, I skipped this one. We are doing the 4. This is a lot easier than what we just saw. So you'll do that on your own. Okay, I think I'm right? I'm not gonna check the answer. Alright? Do you see any mistakes? Okay, let's not waste time then. Okay. Now, what is the rest of the section? We are going to be introduced some theorems, facts that's going to be helpful in the other section actually, finding zeros. So we kind of also find zeros here as well. Okay, but let's first read the first two. It's called remainder theorem. If you want to find out remainder of a polynomial, remainder of a division quickly, and the divisor is in the form x minus c, all you need to do is enter c into the function. Okay, let me repeat. Such as this question. I'm wondering what the remainder is. We already figured it out, but how long did it take for us? We need to do all this computation 3 minutes, sometimes 5 minutes. I'm wondering if I can divide this by this quickly and get only the remainder. All you need to do is, if this is f of x, if you want to find out the remainder of x plus 1, you just need to plug in -1 in there, opposite of this number. Okay, that's exactly what it says here. Look, it's -c, negative, but this thing is positive c. It doesn't have a minus sign, so we always use the opposite. Important. So let's test if this is telling the truth or it's just nonsense. Plug in f of -1 in this function. 4 minus 2 minus 1 minus 6 minus 1 squared minus 4 minus 1 to the 4th. This is 1. This is 1. This is -1 times -2, which is positive 2. -6 times 1 is -6. -4 times -4. Cancel. Cancel. -4. Voila. I got the same answer under 1 minute. How amazing is that, right? So this is a good tool if somebody is just asking what's the remainder when you divide this by that, then you just need to enter c in there. But I believe you can use this for your zero finding purposes as well, right? Can you use this for another reason or cause? Look, if you are wondering if x minus c fully divides, f of x fully divides means zero remainder, all you need to do is enter c into the function and see if this is 0. If there are no remainder, that means x minus c completely divides f of x. That means it's a factor. And if it's a factor, we call c to be 0 or x-intercept. That will be coming next. I was just early. Okay, I was just introducing you the next one. But okay, we will come back to that. Let's first test this out. in the next question, they are wondering what the remainder is. No, it's not. It's not asking for. They want to use this opposite of the theorem. They want us to find k of t too. Okay. Now, but they want us to find k of t too by using the remainder theorem. I know this is ridiculous, but how would you find k of 2? I know you could just substitute that, right? 2 cubed minus 2 squared minus 21 times 2 plus 3, right? That's k of 2, how you find it, correct? But they say, no, don't do this. They say, use remainder theorem to find out k of 2. How else can you do it then? If this is not a lot, this is not remainder theorem. K of 2, another way to understand k of 2 is, this is the remainder when k of x divided by who? By whom? K of 2 is a remainder. You're gonna get a remainder value. I can compute it, but when do we get that remainder? When you divide this by special expression, which is when do you get whatever the value this thing is? Right. When you divide k of x by x, an opposite of this number. And if they forbid us using this simple calculation, so how do you get then k of 2? All you need to do again is take this thing and divide by x minus 2 to get that remainder. If you're not allowed to compute straightforward. So you will put 2 here, 7 minus 1 minus 21, and 3. And do the syntactic division. So this is 7, 14, 13, 26, 5, 10, 13. So the answer is 13. That's it. See? Got it? Do we really get 13 when you do the regular computation? 2 cubed is 8. 8 times 7 is 56. 2 squared is 4. Minus 42 and 3. This is minus 46. 10 plus 3, 13. Yep, match. They just want us to, I mean, everybody can do this, right? Everybody can compute this, but can you do this by synthetic division and get the same answer? Yeah. They're just using remainder term. They just wanted to use, but in my opinion, it's just ridiculous way of computing k of 2, right? Still, we're just showing off. We know a better way. So I'm not gonna do the rest of these. So it's number 5. We get 13 first, but they will just give you more and more numbers. You will just do more and more synthetic divisions. I just need to do the remainder theorem. So I don't know the answer for this one, but you're gonna do synthetic division. Alright, next. I said a new theorem. If you substitute a number into f and get 0, then we already know x minus c is a factor of f of x. And the opposite is correct too. If you know x minus c is a factor of f of x, then f of x equals 0. So what do I mean by factor? Such as f of x, I'm giving an example. It's x squared minus 3x plus 2. Can somebody factorize this? There are two factors of this thing. X minus 2 and x minus 1. So what does this theorem say? It says if you enter a number here and get this thing 0, that number will show up on these factors. Let's check. I plug in 2 here, 2, 2, and I get this thing 0, right? Because 2 squared is 4, minus 3 times 2 is 6, minus 6 plus 2 is 0. So that means this number will be one of the numbers in factorization. Is it really the truth? Yeah, but it's opposite. Always look, whatever this number is, we take negative of it. It's opposite, always shows up. Now let's test 1. Plug in 1. Do we get 0 as well? Again, 1 squared minus 3 plus 2. It's 0, right? And did 1 show up here? Yeah. So this factor theorem is actually something you know. So if you find a 0 maker, it pops up in the factors, and the opposite is correct as well. If you know factors, x minus 2 and x minus 1, if you want to find out the 0 maker, all you need to do is take opposite of these numbers. 2 and 1 are 0 makers. Look, 0, right? X minus c is a factor, then it's a 0 maker. If you have a 0 maker, then it's a factor. All right? So zeros and factors are pretty much the same thing. Find the 0 of function, you know a factor of the function. Find the factor of the function, you know a 0 of the function. Okay? Got it? What's the third meaning of a 0? Geometrically on the graph. Zeros are special locations where your graph makes what? Intersect. Yeah, they intersect x-axis. So zeros, as it's clear from the name, they make the function 0. Okay, they make factors, and they also make x-intercepts. So there are 3 meanings. 1, 2, 3. When you have a 0, you plug it in f, it makes 0. Of course, that's the definition. Secondly, they make factors, opposite of zeros, make factors next to x, and they are also the locations x is crossed by the graph. All right, let's go take a look at this question. What is the question here? Let's read. Use factor theorem, the theorem just above this statement. We will use that to do what? To determine if the given binomial, there are 2 parts here. In part 1, you are given x plus 2. You're just wondering if x plus 2 is a factor of this thing. There are other factors, of course. I don't know them. We don't know them. I don't know how many. It can be as many as 4 different ones, or it can be as many as 1 raised to the 4. We don't know. But is x plus 2 really a factor of this thing? How can you test? Perfect. Plug in minus 2 opposite of this number here and see if you get 0. This is the fastest way. What is another long way? So you're using factor theorem. This is how you're supposed to do. But what is another way you can do? I want you to say if 3 is a factor of 81, what would you do to test it? Divide. Factor means divisor. It should divide the number. Does 3 divide 81? Yeah. How can you prove that to me? You take 81 here and literally divide. 3 goes into 8 2 times, etc., etc., right? So one another thing, if you don't see this statement, it just says determine if the given, you just need to divide them. Put this here, x plus 2 there, and divide them. Or do synthetic division. Synthetic division is minus 2, and then line. And what do you expect to see? You need to get 0 remainder. 0 remainder means it divides it. 3 does not divide 10 because there is a remainder, right? 3 does not divide 10, the remainder is 1. So if you see 0 remainder, yeah, it's a factor, it's a divisor. Okay, but again, what's the purpose of this question is to use factor theorem, and for this all you need to do is test if this thing is 0. Have you tested though? May not be because I don't know yet. What is this total number? Alright, this thing is 16. This thing is minus 16, so they cancel. This thing is 428. This is minus 4, minus 24. 28 minus 4 minus 24, perfect, 0. Got it? So this thing is yes. How about x minus 5? What number you're going to plug in this time? Positive 5. Perfect. 5 to the 4th. 5 cubed. This is 2 times 5 cubed, not 25 cubed, okay? And 7, 5 squared, 2, 5, 24. That's 625. And that's 250. 35, 185. No, 245, right? No, this is 25. So it is 175. Ten minus 24. There is no way this thing is 0, right? Because this is huge. Correct? It's not. No. Questions? Again, the way you're supposed to solve these questions, but it's not guessing. By the way, if I made the wrong choice. This is not x plus 2 is a factor. This one is not. By the way, in the exam, if there is only yes no type question, you won't have multiple shots. You will have only one shot, okay? But if you are providing the answer, you will have many chances, as many as you wish. Here, you have unlimited attempts. But in this question, you will have only one shot. Like I did. If you're careless like this, it will tell you the correct answer. You will never go back to this question. So be careful. No trial and error option. Okay, we're continuing with one more question. It says find complete factorization of this cubic polynomial. It's cube x3 x cubed blah blah blah. But we are given one fact. Minus 2 is a 0. How does this help us? Look, if this was not given, let's say, and they ask me to factor this, I have no clue. Usually to factor this thing, you try to group this into 2 by 2. Actually, no. You try to factor this first 2 first, and factor this, and then refactor. But I don't think it's gonna work. You can't factor this by hand. It's not easy. But if it was only 3 terms, I had some ideas. For quadratic polynomials, you have quadratic formula. You can find the factors. But for cubic, it's too hard. We have help. Help arrived. You know that minus 2 is a 0. So what does this tell you? What's that? Yeah, when we divide by x plus 2, there is no remainder. That means x plus 2 is a divisor, or more properly, x plus 2 is a factor. So can I put here x plus 2? Start this question with x plus 2. All you need to do is guess the other piece or pieces. It may be two pieces, but you need to start with a big chunk piece and then you break this into two more pieces. What is the other bigger chunk? You already have, you are given this. Thank you. They have given a piece of the monster puzzle. You just need to find the remaining two pieces, maybe one piece or two pieces of the puzzle. How can I find this piece? Any ideas? Okay, let me make a simpler version of this question. 81. And they have given one of the factors, 3, just like that. 81, first piece is given, and they are asking for second piece. How would you get the second piece? What operation do you do? Division. Why don't you do the same thing here? The left side is this guy given. You are given this. How would you find that? By dividing, right? Correct? Divide both sides by x plus 2, or divide this guy divided by x plus 2. So let's do it. What's the most fastest way? Long division? Synthetic. Let's do this synthetic. I'm gonna do synthetic to divide by 2, so I will put 2 here. Is that right? And put these guys right here. 3, 22, minus 3, minus 70. Any comments? Right, it's supposed to be negative 2. Perfect. And then we put a line, bring this down, multiply, add, multiply, add, multiply, add. Minus 2 times 3 is minus 6, 16. Minus 32, 35. Minus 70, positive 70, 0. Were you expecting a 0 here? Yes, if you're not getting a 0, you made a mistake. Go check. Because we already given it's a 0. No remainder should remain. Okay? Alright, then what is this piece? Quotient. Perfect. This guy will go here. Okay? Alright, how? Minus 35 first, 16 next with an x, and 3 going first place with an x squared. Isn't that great? Okay, so we have now this, and you guys know the big chunk. Your job is to break it into two more pieces. How do you break a quadratic function 3x squared 16x minus 35 into two pieces? Two factors. First thing you're going to do is trial error. Try to find out by hand, by logic, what numbers come here. When you FOIL it, it becomes 3x squared. So what two numbers multiply into 3? Yeah, so I put 3 here, 1 there, x and x. Okay, now I'm going to guess the other two. These two question marks will multiply into minus 35. And when I FOIL outside and inside terms, they will add into 16x. Two numbers multiplied make minus 35, and you FOIL and add them, that 3x and x multiplies them, and add to minus plus 16. What two pairs? Chris?
Negative 5 and 7.
Let's test. Negative 5, positive 7. Okay, let's multiply outside terms. 3x times 7 is 21x. Minus 5 times x is minus 5x. When I add them, do I get the middle term? Yeah, perfect. So we found it. We found it. Got it? So what is the story we got here? Cube equations are monster. They are too hard to factor. So they give us a simple weapon to reduce them, shrink them into from monster to, this is just a something you don't scare of. Okay, we shrink it into something you very well know, and you know how to factor that those things because these are quadratic. Quadratic ones are usually can be found by guessing game. At least in the starters, it is like that. There will be some quadratic ones, like if this was 2, you could never guess the answer. Now we will need to use quadratic formula, which we'll see in the next section. We will have more tools or weapons to hunt this down. But this one, for starters, you can guess what multipliers numbers are here. Okay, I think we have the last question here. Test this one quickly. Was +7? No, it was the other way, right? So order important. -5 was the first one. Okay. There's a second part. So they want us to set this into 0 before going to the next one and solve it. But once I set this into 0 and solve means you set each and every part, this guy, into 0 and solve. Okay? And what do I get in the first part? X equal -2 goes here. These are called the zeros of the function. But it's already been given to us, the first one. So the first one was a no-brainer. So you already have that in the pocket. The second one is when you add 5 and divide by 3, 5/3, right? 5/3. And the last one is 7. Correct? No, -7. It's always opposite of it. Take opposite of this thing. It's -7. Now we're good. Okay. So we also determined. I mean, the reason they asked us to factor is actually to get zeros. We will do this same question in the next section. Much more solid process. But this one is kind of lucky. We were lucky to find out the last two pieces by guessing factors. All right. Next question is, they have provided us zeros of a polynomial. They have provided us the leading coefficient. They want us to build a polynomial satisfying these given data. So there is a polynomial. We know it's degree 2. That means it's a quadratic one, square function. Something x squared, something x, something c. And what we know about it is it has the leading coefficient 1 and 2 zeros. Okay, here is the fact you need to know. Every polynomial starts with an a and then z1, x minus z2, x minus z3, etc., etc., zn. What z stands for? 0. So if you know zeros of the polynomials, you just supply them in z's. If you also know the coefficient or the leading term, leading coefficient, you supply here leading coefficient. That's how you build the entire polynomial from the roots or zeros. However, they say this is a degree 2 polynomial. It can have as much as two zeros. So you don't have third, fourth, fifth zeros. You wipe these off. You wipe off the remaining ones. You have only two zeros. So it's z1 and z2. And one leading coefficient. Leading coefficient is given as 1. So I substitute 1 here. What are the zeros then? It doesn't matter which order. You put the first one here, the second one there. Yes. We always go with the opposite of the sign here because there is an extra negative. Negative of -5 is positive. This one is positive. Okay? Oh, this one is 15 as well. Thank you. Alright. This is it. This is a kind of very simple fact-checking question. Oh, I got double inequality, double square root. How do I clean the first one? Yeah, I may have to clean the entire thing here. What did I do? Oh, we should multiply this out. Yeah. They want us to enter a result, so we need to multiply this thing. Foil it. But isn't this a minus a plus b, x plus b, that fact? Do you guys know what happens? No. A minus b, a plus b. If you have two conjugate factors, when you multiply them, it's just square of each. So I know quickly this is x squared minus 5 root 15 squared. But if you FOIL it, the middle two terms will cancel each other. They will be opposite of each other. And we will get 5 squared is 25. And 15 is 25 times 15 is 280. Right? No, 275. Okay. So this is it then. Look, you square 5, do square root, it's just 15. 25 times 15 is, no, I'm wrong, 375. Right? I'm glad I have multiple attempts here. Good. Alright. We're gonna stop here today. And on Monday we are starting 3.4. Kind of continuation of this process. We will continue finding more zeros. Alright. But much more precise method, systemized method, and more tools. We will learn about rational zero test, Q over P test, and it's gonna be a little bit longer though.